friends. Hi friends. I am going to explain the continuation part of graphs. In the previous video I discussed about introduction part of graphs and types of graphs and graph terminology. Now I am going to explain an important concept of graphs, that is called graph representation. So what is the graph representation? So we want to store a graph in a memory location. So that is called graph representation, or how to store a graph in a particular memory location. So how to store a particular graph in a memory location? We want to store, we are using some structures, data structures. We want to write a program to a particular graph. So we are using some data structures. So here we want to represent a graph in a particular memory location. We are mostly using two types of representations. One is adjacency matrix. The second one is adjacency list. First one is adjacency matrix and second one is adjacency list. List means linked list. So come to the first one. Adjacency matrix. So here we need to recall our previous concept regarding to arrays. So how to represent a matrix? So by using two-dimensional array, we need to represent a matrix. Why? Because the matrix containing rows and columns. It is a mix of rows and columns. My student friends, you need to remember how to declare the two-dimensional array. Here we are using not one-dimensional array, we are using two-dimensional array. We want to represent matrix, we are using compulsory two-dimensional array. The two-dimensional array follows the structure of rows and columns. So what is the syntax of array? So that is the syntax of array. Array, data type, array, variable name, array, variable name, row size and column size. Row size, column size. For example, data type. Suppose I am using integer data type. The keyword is int ARR of 15. It is 50. So what is the meaning of this? This is the data type. ARR means what? Array variable name. This is the row size and this is the column size. So we want to represent a adjacency matrix. We need to use int ADJ of I and j. That is the meaning of here I is the rows, columns and j is the rows. So that is the size of row and this is the size of the column. That means ADJ is nothing but ARR of 15. That is 50. This is the meaning of this. This is the name of the ARR is the name of the array. This is also the adjacent matrix array variable name. So like this we are going to declare a two-dimensional array with this syntax. Here mostly we need to remember the array follows the order. It's not a random memory location. It stores the value in sequential order. That is, the array is in order. It is homogeneous. Already we know that. Means the starting value is go and stored in 0th index. The last value is go and stored in n-1 index. So here in this adjacency matrix, we need to remember two things. ADJ is equal to ADJ of I j is equal to 1. ADJ of I j is 0. We need to remember these two mentioned point. Adjacency matrix of I j. I means row, j means column equal to 1. Adjacency matrix of I j is equal to 0 means it indicates this. The first one is indicates there is a connection between I and j, means there is a edge between I and j, means there is a edge or link between row and column. And this means the second one is going to indicate there is no connection between the edges or vertices. There is no connection between the vertices. So there is a connection between the vertices. There is no connection between these vertices or pair of vertices. That is the meaning of these two former examples. Here I am taking one graph. I am using a undirected graph. Okay, I am using this graph. I want to represent this graph by using adjacency matrix. The matrix contain what ma? Rows and columns. Rows and columns. How many nodes are there? 0, 1, 2, 3, 4. Totally 5 nodes from 0 to 4. Here also we need to mention 0, 1, 2, 3, 4. So this is the template of matrix representation or adjacency matrix representation of a particular graph. Here n is equal to number of vertices. N is equal to number of vertices. Here size of matrix equal to the size of matrix is equal to n into n. The size of matrix is equal to n into n. So how many vertices we are using ma? 5 vertices we are using. That is 5 into 5. How many cells is there? How many memory location is occupied? 25 memory locations is occupied in a particular storage. So according to this graph size. So this is a matrix representation. Now we are going to give a link according to two main points. What are those? ADJ of I j is equal to 1 and ADJ of I j is equal to 0. So this means what ma? It indicates there is a connection or edge between pair of vertices. This indicates there is no connection between pair of vertices. Come to this one. First one 0. 0 to 0. Any edge is there? There is no self loop now. That's why there is no edge in between 0 to 0. That's why we need to mention 0. There is a connection. There is no connection. We need to represent with the 0. Boolean values we are using. What are the Boolean values? 0 and 1. 0 means what? False. 1 means what ma? True. Next one. 0 to 1. 0 to 1. As there is a connection. That's why I need to represent with 1. Then 0 to 2. There is no direct connection. That's why that is 0. 0 to 3. As there is. 0 to 4. No, there is direct connection. Next one. 1 to 0. 1 to 0 as there is a connection. 1 to 1 there is no self loop. 1 to 2 as there is a connection. 1 to 3 there is no direct connection. And 1 to 4 there is no direct connection. Next one 2. 2 to 0. There is no direct connection from 2 to 0. That's why that is 0. 2 to 1. That is 1. 2 to 3. Yes, there is a connection. 2 to 4. Yes, there is a connection. Sorry. There is no connection, direct connection. There is no self loop. 2 to 3. S. 2 to 4. S. Next, 3. 3 to 0. As there is a connection. 3 to 1. There is no direct connection. 3 to 2. As there is a connection. 3 to 4. As there is no connection. 3 to 4. There is no self loop. There is a connection. Next, 4. 4 to 0. There is no direct connection. 4 to 1. There is no direct connection. 4 to 2. As there is a connection. There is a connection. 4 to 3. As there is a connection. 4 to 4. There is no self loop. So this is the matrix representation according to this graph. Sorry, understood how to mention? So we are having the connection or link or edge between pair of vertices. We need to mention with 1. Otherwise, we need to mention with 0. We need to remember these two important points. According to these rules, we need to make this adjacency matrix for this particular graph. So, what is the second one? Adjacency list. Why we go for adjacency list rather than by avoiding this adjacency matrix? We need to use sometimes, but why we are using second type? Why we need to go for second category? There is some problems in this existing one, then only we will go for second one. So, to prevent this existing problems of particular type, we will go for second type. So, first we need to identify what are the problems. So, here we need to observe memory means nothing but it depends upon space complexity and time complexity. Space complexity and time complexity. Space complexity and time complexity. Here we need to observe in this memory location. So, what are the locations are mentioned with 0? Those are filled with the value. What are the locations are filled with 0? That is wastage of memory in a particular array. So, this much of space is wasting. So, that's why in this type, the size of the memory, the space of the memory is wasting. This is the sparse matrices. Actually, we have to consider this is. Okay, now here the disadvantage means here the much more space is wasting unnecessarily. So, why we need to tell this? What is the size of this matrix is n into n. That is called order of the space complexity is order of n square. Order of n square. N into n means column vertices and row vertices. N square means what, ma? This is the column vertices. These are the row vertices. So, much more space is occupied unnecessarily. That's why it is wasting of our time. That's why this is order of big O means what? Order of n square. But the time complexity. The time is saving here first of all. That is order of 1. Big O of 1. Not 0. Big O of 1. So, what is this is a very time is saving here. But the space is wasting here. Time is saved here. How? Here we want to know there is a connection between, there is a connection in a particular cell. Suppose we want to know there is a connection or edge between 2 to 4, for example. There is a edge between 2 to 4. Where is 2? Here. Where is 4? This is here. 2 is row, 4 is column. That's why we need to. So, 2 is column, row. So, this is row. 2 to 4, this cell. 2 to 4 means what, ma? This cell. There is what? 1. 1 means what? There is an edge between this pair of vertices. So, like this, we need to find out there is an edge maybe there is an edge or not. And also we need to easily insert an edge, or easily we need to delete the edge. Edge means we need to insert the nodes and we need to delete the nodes. We need to find out the nodes. So that is the one advantage in this. Here the time is saved. Directly we need to find out there is a connection between the pair of vertices. But here the memory is wasting much more. That's why we are going for the second category, that is called adjacency list. Hope you friends, are you understood this adjacency matrix, how to represent a graph in this form? The second category is adjacency list. List means what, ma? Linked list. List follows what? Node structure. Already we learned what is the node, what are the elements or fields are having in a particular node. So say for the same graph, I will explain you. Yes, is the same as what is V. N is equal to number of vertices here we are going to represent. So what are the vertices? 0, 1, 2, 3, 4. And also outside we need to write same vertices 3, 4. These are the heads. So here we need to give the links. The list contain what, ma? Links. The node, every node is having the link. Node link. These are called head. And all heads are nothing but vertices. So from 0 we are having the link 0 to 1 and 0 to 3. So there is no other links from 0. The last cell is stored with null pointer. Null pointer. Next one, consider 1. From 1 to 0 we are having, 1 to 2 we are having connection. There is no another things, we can represent with null. Next 2 to 1, 2 to 4, 2 to 1, 2 to 4. Then next one is null pointer. Last cell is stored with null pointer. Next one 3. From 3 to 0, 3 to 4. Next one is null pointer. Next 4. 4 to 2, 4 to 3. 4 to 2 and 4 to 3. Last one is null point. Okay, this is a linked list representation of a particular graph. So these are all heads. These are all what ma? Links. We want to maintain the links in between pair of vertices. Here we need to give the links between all vertices. 0 to 1, 1 to 2 and 1 to 3 and 1 to 4. These are all heads. Okay, this is the edges. Last field is stored with the null point. So like this we are going to represent. Here we need to save the space. How we can save the space? Directly we need to give a link. By using link we need to find out how many edges are there. So from 0 directly we need to say that from 0 we are having edge from 0 to 1 and 0 to 3. 0 to 1 and 0 to 3. From 1 we are directly find out the how many edges we are having. 1 to 0 and 1 to 2. Like this we need to find out easily. There is no space is wasting. There is no null, there is no zero spaces here. So what the locations or edges are having, then only we are mentioned here. So there is no space wasting here. Okay now. So according that is the advantage of adjacency list. That's why I are using a second category most, that is the adjacency list. So this is the space complexity. Here the space is less space. It occupies less space. That is the advantage. That is order of number of vertices plus number of edges. So vertices plus number of edges. So here time complexity. Here the time is wasting. More time it will take. More time it will take. How we need to say that more time it will take? Suppose we need to find out there is a link from 2 to 4. There is a link or edge between 2 to 4. So we need to go through that 2 to 2, 2 to 1, 2 to 4. Here the checkings of the observation, the finding takes time. In the first category it is very easy. Directly we are finding. Here we need to search some links or some edges. We need to go through some edges. Like suppose we need to find out there is a link between 3 to 4. We need to go for 3 to 0, then 3 to 4. So in this case the time is wasting. That's why the order of the big O of time complexity is size of vertices plus size of edges. So we need to find out where it will be end. So we need to go through this all these links. Then only we need to find out maybe it is end or not. This is also another disadvantage, but here the time is savings much more. So here less space is occupies but more time is taken. In the first category it will occupies much more space and less time. These are the two types of representations we are using to represent a graph. The first one is what ma? Adjacency matrices. What is the second one? Adjacency list. Which matrix we are using? Two-dimensional matrix. Why? Because it can follow the rows and columns. We need to recall that two-dimensional array. What are the types of arrays? There are two types of arrays. Single-dimensional array and multiple-dimensional array. Either row or only row and either it is a row, either it is a column, it contains it is single-dimensional matrices. but we are containing both rows and columns together. That is called two-dimensional array or multi-dimensional array. Okay, we are using multi-dimensional array to represent the adjacency matrix. Here we are using linked list to represent the nodes and vertices, their relationships according to like this. So hope you friends, are you understood how to represent the graph by using these two ways. I request all of my students, you have to prepare a note according to my lectures. Thank you one and all.